Okay, lastly, we're going to look at division of complex numbers. So the big thing you need to realize about a complex number is that when we talk about I, remember that is still equal to the square root of -1. So I is a radical. And if you remember from simplifying radicals that we had in the previous set of lessons, okay, we cannot have a radical in the denominator, okay? So I cannot be in the denominator. So how are we going to go ahead and get rid of it if we have a situation like we have here with a fraction that has a complex number in the numerator and a complex fraction in the denominator? And the key is, this is where the complex conjugate is going to come into play. Okay, so what I need to do in all of these cases is I need to multiply by the complex conjugate. In order to get rid of the I in the bottom of the denominator, and then we will write our solution, okay, as in standard complex form. So with a real part written as a fraction and an imaginary part also written as a fraction if needed. Okay, so in this problem here, okay, I have, I'm going to rewrite it actually. So I have 4 minus 3 times I over 5 plus 2 times I. So I'm going to multiply the top and the bottom by the complex conjugate 5 minus 2I. Okay, because I want the imaginary part in the denominator to go away. So for the numerator, I need to FOIL. So I go first, 4 times 5 is 20. Then I'm going outside here. So I have 4 times -2I, that's minus 8I. Okay. Then I'm going to go inside. So I have -3I times 5, that's going to be -15I. And then finally I have last, so -3I times -2I is plus 6I squared. Okay, now then for the bottom, I'm multiplying complex conjugates. Okay, I don't need to do the whole FOIL thing. What I'm going to do is I am going to square the first. So I'm going to square 5. So 5 squared, okay, minus, and then I square the second part, 2I squared, like that. Okay, so I know that this 6I squared, okay, is actually going to be -6 because the I squared equals -1. Okay. So I have 20 minus 6, which is going to be 14. Okay. And then 8I minus 15I is minus 23I. And all that is going to be over, well, 5 squared is 25. And then minus 4I squared, okay? But 4I squared is just, or -4I squared is just going to be 4. So in other words, I'm going to have 14 minus 23I over 25 plus 4, which is equal to 29, which is equal to 29. So 14 minus 23I. Now then, I need to write this as a complex number. In other words, I need to write this in the form A, a real part, plus B times I, an imaginary part. Okay, so in order to do that, all I have to do is take this fraction and break it up into two pieces. I have 14 over 29, and then I have minus 23 over 29 times I, and that is my answer written in proper complex form. All right, now then, on the other hand, if we take a look at a problem like this, 6 plus 5i over the square root of I, okay? In this case, okay, all I have is the imaginary part. So all I need to do in this case to rationalize my denominator is to multiply both the top and the bottom by I. Okay? So when I do that, I'm going to have to distribute the I to both pieces in my numerator. So this is going to be 6i plus 5i squared. Okay? And then I have over negative I squared in the denominator. So, okay, 6i becomes my imaginary part, so I'll put that in the back. Okay, and then the 5i squared, remember I squared is -1, that just becomes -5. So the numerator becomes -5 plus 6i. And in the denominator, I squared is -1, and the negative of -1 is +1. So my solution here is just -5 plus 6i.